Matt, please. Hello, everyone. Today is Wednesday, 3rd of September, 2025. This is the Cluster API Office Hour. Usual reminder that we abide to the CNCF Code of Conduct, so be kind of each other. So we have an agenda meeting doc. If you have please write your name at the top of the agenda. And if you have topic to discuss, feel free to add them to the agenda as well. Okay, as usual, at the beginning of the meeting, we welcome new attendees. So if there is someone that is for the first time or that attend this meeting and want to introduce themselves to the group, feel free to speak up.
So hi everyone. So my name is Hussein. I'm basically from Germany. So actually this is my second meeting. So I'm looking forward to basically contribute to Kubernetes technology. Yeah, thank you.
Thank you very much for speaking up, introducing yourself, and looking forward for your contribution. Yeah, feel free to reach out in chat in the Slack channel if you need some guidance. Is there someone else that wants to speak up? Looks not. So let's move on with our agenda. Open proposal readouts. Okay, so I'm going to remove chain and efficient upgrade because the proposal merged last week. And so we have two. Propagate tains. Is there someone that wants to speak up? Nolan or Matteo?
Yeah, there's not a whole lot of movement on it. I need to get to updating it, but I should have time to do so this week.
Okay, thank you very much. From my side, basically, yesterday we finished the work for release and Kubernetes support for 124. Today or yesterday we worked also on preparing the new branch for the new release cycle. And thanks, Christian, for taking charge of this work. And so looks like we are quick. We also merged the PR with the control runtime bump. So I'm quickly getting to a place where I can start looking into new proposal. I'm starting from in place because we already have a prototype out, and then I will move to this one. So yeah, getting there. Please be a little bit more patient. Okay, independent worker topology. Is there Joel or Igor that want to speak about?
Yeah, just waiting for feedback on that. We moved it to a Google Doc like we talked about. Let me check. I looked earlier this week. It didn't look like there were many comments yet, but
Yep. Thank you. I think that yeah, for me the same apply. Getting there, I will. I'm trying to get rid of the backlog.
perfect. Thank you.
I think the same apply for other maintainers as well. Okie dokie. So that's all for open proposal. Let's move to the agenda. And the first one is Andreas.
Yeah, I haven't been around for like half a year. Back from parent leave, back full time. So just saying hi again, as if I was a new attendee. Yeah, so what I wanted to say, since I saw last week's entry about the call to action for machine pools again, I said it a few months ago and again now, I'm happy to work on this. So very happy to partner with Matt and Richard, maybe split up some tasks. Definitely want to write down a good contract because we're missing that. And yeah, my company Transform has also been working on machine pools the last months still, and keep seeing feature needs and bugs and such. So I have the bullet point here, what we found, which is kind of an edge case where like there's just no version skew control in machine pools. And I was thinking maybe someone has ideas because usually those generic things are solved in CAPI and not on the infra provider level. But it looks like the infra provider kind of has to do it. Would be nice to just get some ideas. I don't have an issue for it yet. I might open one. We definitely want to contribute on Kappa for this right now because that's our use case. And the case here for us is we update both the control plane and the workers at once. So all the manifest is one deployment. And then if workers roll out first before control plane is finished, then could be a big boom if they are not compatible Kubernetes versions. So that's version skew, for example. And yeah, I think we want to solve that because we have lots of custom upgrades, which should be fully automatic. And I'm also happy to work on other topics. I guess that's it. I don't have any issues, PRs, links yet. Just yeah, maybe Matt and Richard, we can. I guess Richard's not here, but maybe we can have a talk or a chat, split up some tasks in the tracking issue.
That would be great.
Yep, echo this. So first of all, welcome back and congratulations. I'm happy that we are reaching a critical mass for addressing the issue with machine pool. With regard to the issue that we are discussing, this is interesting because so I don't have an answer. I just want to share that there is a similar issue that we triaged today. It was about so it was slightly different. So it was about machine deployment. That when you apply changes, there is no synchronization between the two. So to angle at this, we have from one side we have cluster class that sort of solves all this problem by looking at the entire cluster and not dealing with many separated resources. Going one level deeper, what we implemented is what we address as similar problems, but probably not all the problems, by implementing per-flight checks.
Which is for machine sets, but
yeah,
not
we
for
have
machine
per-flight
pools.
check from machine set and from machine pools. Sorry, for machine set and for KCP. And the idea is that basically we do not create machine when we know that those machine, we already know that those machines are going to be rolled out soon. And there are a couple of conditions when we do so. Today we were discussing, we were looking at this other issue that I don't remember. I will search it up later and figure it out if we can address the issue by having similar profile check at machine deployment level, and looks like we also need at machine pool level. So I don't have a solution, but it will be nice if we try to stay consistent with the pattern that we already have in CAPI. But yeah, that's the discussion to when you have a solution. Stefan?
Yeah, just one comment. So I think it makes sense in general to have that for machine pools. There's just one big difference between machine deployments and machine pools. And basically for machine deployments, you have core CAPI making the decision when to create a new machine. While in machine pools, like let's just say in general, 95% of implementation is in the infra provider and in the infra machine pool. So I don't know if you'll find a way in the core CAPI machine pool and machine pool implementation to basically block the infra machine pool from doing things. But yeah, let's just see what is possible and what makes sense. Maybe there is a way. I don't know enough about implementations. That could be a difficulty, that maybe they just go ahead and don't even wait for anything on the core machine pool happening, or the core machine pool controller doing.
Yeah, right now there's no such feature at all. And the infra provider could easily do it by comparing the machine pool version against the control plane version, and then going ahead or not, if that's even possible. I guess for some machine pools it might not even possible to like pause or stop. And if you want to solve it on CAPI level, then I'm quite sure it needs to go into the contract, like a status field about the version skew, a condition or something that infra providers then optionally can read, which would be forward compatible. So that's cool.
Or potentially a util function that people should usually call in their infra machine pool controller flow. I mean, I don't have a strong opinion. I'm just mentioning options here.
Yep, going back. So if you want something in CAPI which is more than a util, the counter is really key, because unfortunately, based on my understanding, machine pool exists in a few different flavors, and for me it is really difficult to understand what we can rely on when implementing stuff in CAPI. So defining basically the contract, what exists in machine pool when there are machine pools and when there are not, and maybe some other variants that exist, is crucial to take a good decision and good test coverage, etc. But yeah. Again, thank you for volunteering.
One more question about this.
Yes.
Since I want to get more into the machine pool topic, does someone have a list or experience like which machine pool implementations even exist? I know about Kappa and CAPC, which have 2 implementations each, managed and unmanaged. I'm not sure which providers try to implement it other than those 2.
I think Oracle, maybe. I'm not sure.
And I know that, and if I'm not wrong, also Google showed up showing interest about this. I don't know if they already did something.
So there could be a correlation that if you find a provider that implements a managed control plane, they very likely also have a machine pool. But I don't know if that helps you.
Just changes. I'll try to have a look. Okay, cool. Yeah, I guess the topic is finished. I'll try to go ahead and talk to Matt and Richard about the tasks and go on with our topics as well. And probably regularly try to review PRs and issues around that area just to get more into it. Cool.
Thank you very much.
Thanks.
Help is very, very welcome. Okay, Matt.
Sorry, I was just typing something. Thank you. This is just to let people know that patch releases are available for 111 and 110. There's a few interesting things in 111 and not a whole lot in 110, but we wanted to sync them up again, so we're doing monthly patch releases for both lines. And I don't think any of them, Pavel is here, but thanks very much to everybody who volunteered. We had really good support, and I think it went really well. Yep, that's all for that, unless somebody else wants to weigh in on the patch releases. And then somewhat related to that, the next topic is, I think we have the members of the release team set. I'm just waiting another day or so for feedback from some of them in case people want to switch teams or bail out. And then I'll open a PR that updates the docs, and then the team is set. So some familiar faces and a lot of new people.
That's great to hear. Thank you, first of all, to you for all the work that you did in the last 2 releases. And yeah, looking forward for the new release team.
And thanks for beating the drum. People listen when Fabrizio puts out the little alert beacon. So I got a lot of volunteers after that.
Great, really great news. If there are no questions for Matt, we can move to provider update.
And I guess this is me again. Yeah. This is
sorry,
just
there is Stefan first.
Oh, I'm sorry.
Yes, maybe just a quick FYI because we just figured it out, and maybe that's relevant to anyone. I don't know how much it is relevant, but I'm just want to mention. So basically, Christian found something in CI, and what it is basically that we noticed that controller gen has been generating slightly invalid CRDs like forever. And the problem is that when you have a field which is of type integer, it also adds a format, and that format is int32 or int32 or int64. Our assumption is that basically API server always ignored this, and it will also continue to ignore this. But with 134, they basically started adding warnings to tell you that like int32 and int64 is not a recognized format. So of course, I will going to open a PR in controller tools to like fix this and stop setting this into that format. But just as like a heads up, whenever you're going to apply any of the CRDs that have been out there today and they have an int field, you will get a warning from the API server that you're using a format that does not exist. Probably it's not like, I mean, it's a warning, it's noisy, it's not great. It shouldn't break anything. But yeah, at least you know now. Going to try to fix it ASAP.
Thank you for bringing this up and for doing the investigation about this. We just noticed the the error log this morning, and this was a really quick turnaround. Thank you. Matt, back to you.
Yeah, I should have reported this last week because it's actually about 10 days old, but there was a new release of CAPC. And then just like Nolan's about to say, it's still based on V110 and we're working on V111.
Good. That's a good news. Please provide feedback for the V111 integration. Next one, Nolan.
Yeah, just wanted to point out that Kappa v2.9.0 is out. And yep, there is, it is based on 1.10, but there's work to get it onto 1.11. Also, thank you to the folks who tried Kappa with cluster control 1.11. It turns out we found there was a overly strict validation of the metadata kind on files. So we fixed that up, and hopefully that will be less of an issue for people if they're using a newer CAP-B cluster control than the provider uses.
Okay, thank you very much. I also give a quick update about CAP-V. This morning, European time, we released the CAP-V 1.14, which already uses CAPI 1.11, and it has been certified with Kubernetes 1.34. So bleeding edge. So far, no issues. And the Kubernetes certification went smoothly. Also, the last copy bump went really smoothly. And not the same complexity of the first ones in this cycle. So definitely things are settling down. Okay, there are no feature group updates. So we are at the end of our agenda. Is there some last minute topic that we want to bring up? Maybe Mike, do you have some update about the autoscaler issue discussion? I saw some message, but I did not have a chance to properly catch up.
I mean, yeah, I can give an update. Unfortunately, this issue is like, it's very complicated. And, like Stefan and Alberto have been having a really good back and forth discussion there. I'm still doing investigation. Like I'm using the the CapK provider to like study how an upgrade happens and kind of look to see if there's information that the cluster autoscaler could use, to be able to predict these. But I'm not quite there yet. Yeah, and Stefan's comment, you only have to read his fourth TLDR. It's you know, I think the root of the matter here is that as a community, I think we can safely say that if you're using machine deployments to do upgrades, you probably don't want to run the cluster autoscaler on those machine deployments at the same time. That, the mechanics of how the machine deployment replaces machines means that the replica count will for some time period be inaccurate to the number of nodes that are actually associated with that machine deployment. And this causes the cluster autoscaler not to become confused, but like to tell it to remove the nodes, and that causes the replica count to have this kind of interaction. I think, I'm still not clear, and maybe Stefan could talk to this, whether there might be improvements we could make in cluster API to improve how deleting a machine while an upgrade is happening could potentially occur. From the cluster autoscaler side, I'm trying to understand if we can make the autoscaler smart enough to know that an upgrade is happening and then not to request deleting machines that are still under upgrade. But it's not clear that I'll be able to do that just yet. Stefan, please.
Yeah, my opinion is basically that we should do exactly the last thing you were saying, which is basically ensure in the autoscaler that the autoscaler is not trying to delete machines while an upgrade is going on. Basically because of two reasons. So the problem we have at the moment is that while the machine deployment order is going on, if it's stuck in a certain way, there might be empty machines temporarily, and essentially the autoscaler tries to delete them, right? That's like the high level issue. I mean, I think in general it should not do that because the machines that we have at that point in time, they're not like, there's a reason why they are there. And the reason is that someone decided, I want to have a few additional machines so that I'm actually able to move workload over. And the autoscaler deleting those machines basically goes against that goal. That's like my opinion. It's fine. We're just figuring out what to do. And so that's why I personally think that we should just try to make sure the autoscaler doesn't try to delete machines while the machine deployment rollout is ongoing. Also, essentially, at the moment, it relies a little bit on the fact, which is not an API, how exactly machine deployment rollout happens. And also, like, because one of the assumptions didn't work out, we have like now that specific problem that tries to delete a machine, but then the wrong machine gets deleted. And this behavior, even if you're able to predict this sort of correctly, I think it will be still racy, basically to try to sync up two controllers. Like the autoscaler has to anticipate what a machine deployment controller will do in the next reconcile. This is like maybe possible, but tricky. But also, as it is not an API on what the machine deployment controller is exactly doing, this can also change. Which means the autoscaler basically has to co-evolve with whatever cluster API version is deployed if you ever change that logic, which makes it even more complicated. So I don't know if that helped for people who didn't read like the 140 replies on that Slack thread. But that was like my try at a summary.
If I can sneak in here right before Neha,
Absolutely.
I am working to write up an issue for the cluster autoscaler repo where I describe all this. And I want to incorporate, Neha's request from last week, which was to get a sequence diagram in here too. So I'm trying to write this up and get it onto the cluster autoscaler just to explain it a little more, just to help everybody understand what's going on. So please, Neha.
Oh, looks like we lost Nia.
Oh, sorry, I was on mute. Can you hear me now?
Yes.
So you never lost me. Okay. I have two requests. In that sequence diagram, I think it would help to say, if you have max search of, let's say, 1, and whatever autoscaler setting, how does it impact the whole upgrade process? The second would be, does the problem become bigger if your max search is more than 1? How does it, impact the upgrade process? The only question that I want to ask, I know it is being typed right now, that so if somebody's using autoscaler, then the recommendation would be to disable it before you trigger an upgrade or any sort of like rollout basically on your cluster. if using machine deployment, right?
Yeah. Like
Okay.
if you're using cluster autoscaler, I would say that if you are, depending on how you're doing an upgrade, right? Because every organization has different processes for this. But I would recommend that if you're upgrading one machine deployment, that you should probably disable that machine deployment from being included in cluster autoscaling. Like allow the upgrade to complete and then start it again. Now, if you're in a situation where that's not desirable, where you need to have extra capacity, I think the next recommendation that, I think I would make on behalf of this community is you should have two machine deployments then, right? You should have the old one and then you should have a new one that has spare capacity that you can upgrade to. Like it just becomes very like for all the reasons Stefan is talking about, when it's a single machine deployment, doing the upgrade and the cluster autoscaler is trying to manipulate that at the same time, there are just many possibilities for it to go wrong.
Okay.
Yeah, Stefan, you were next.
Yeah, just one additional info and a bit of a spoiler on the max search thingy. So I think you will basically get a bit of different results if you have like relatively low max search values or max search which is equal to the number of replicas. And then generally, if you're looking at a current bug, which is basically very high level autoscale tries to delete one machine and it accidentally hits another one. If you have higher max search values, basically that doubles and triples. So you have max search 1. I mean, depending on what exactly is happening, but in a very simple setup, if you have max search 1, autoscale tries to delete one machine and accidentally deletes one other wrong machine. If you have max search 2, it tries to delete two machines and deletes two other wrong machines. And that is the way this problem scales up. It depends a lot because the problem is not directly that some old machine deletions are stuck. The problem is more that for a certain amount of time, you have you have just machines in general, but very likely new machines that are empty. They are empty because the old machines are stuck in deleting. And basically, the cardinality of how many machines it tries to delete is basically the number of empty machines. So that's why it's not just as easy as like max search is the number of wrong deletions or something. It really depends on like the amount of empty machines you have sitting around while your upgrade is stuck in some way or another.
I think Pavel first and then Nia.
So basically, I was thinking about in-flight updates and perhaps there could be use some annotations that maybe there is external update happening and or maybe some kind of a change, maybe some hook could be also added to make sure that nothing gets auto scaling or removed from the set during this kind of a process. It could be update, it could be annotation correlated with an update, or it could be just custom annotation with some pending hook. Because last time I remember that it was like there were two machines and improper one has been removed. So perhaps somehow correlating this annotation with upgrades would make sense, and perhaps no machines that shouldn't be removed would still stay in the proper machine set. I'm not sure about this yet, but I have found this in-place update document which I'm starting to read and analyzing, and then I think that there might be something in it that could be very important. Same as the proposals here with integration, because even external ETC provider, but maybe that's for now. I'm just thinking about this extra notations during updates, so we know that there is like a hook check, so something has to be met and no invalid machine is removed, especially during update process. Starting with simple annotation.
Thank you, Pavel. Nia?
Oh, Stefan, when you started talking, you mentioned some correlation between the replica count and max search, saying, if max search is
Yeah.
one and replica count is one, but you didn't elaborate more on it later. So
Yeah.
I wanted to understand what was the context
Okay.
behind that. Sorry.
Sorry, absolutely. Okay, so there is okay. There are multiple ways on how happy or not happy like this all of this stuff can happen, right? So the very happy path is something like you do a machine deployment rollout, you actually have spare capacity. The autoscaler is trying to delete empty or unneeded machines, so machines that are too empty essentially, and it is able to delete the right machine, and it's sort of fine. Now the unhappy paths are basically let's say that the first grade of unhappy is it deletes a machine. It is able to delete the right machine, but that's something that you needed for like search capacity or something. But it will still just delete that one machine and nothing else happens. And now the two very unhappy paths. So one is basically you have a new machine that is empty. Autoscaler tries to delete a new machine, and copy ends up deleting an old machine. And the other way is autoscaler tries to delete an old machine and accidentally deletes a new machine. That's just in general what can happen. The way that autoscaler tries to delete a machine is basically it puts an annotation on a specific machine, and then it reduces the replica count of a machine deployment by 1. And now it's the choice of the machine deployment controller to either scale down the old machine set or the new machine set. But it's not, autoscaler wants to delete a specific machine, but it's the machine deployment controller's choice if it's going to downscale old or new machine set and accordingly delete an old and a new machine. So the really bad problem is starting to occur when the autoscaler tries to delete an old machine and the machine deployment controller is scaling down a new machine set, or the other way around. Because then instead of deleting an old machine, we're going to delete a new machine. Instead of deleting a new machine, we're going to delete an old machine. So far, I'm just going to continue. Okay, so, and now the tricky thing is the decision if the machine deployment controller is scaling down the old machine set or a new machine set depends on replica counts, essentially. So between machine deployments and machine sets, and that gets impacted by max search. So what is happening is the following. At the beginning of the reconcile, we first look at the new machine set. If the replicas of the new machine set is higher than the replica field of the machine deployment, then we're going to downscale the new machine set. And otherwise, we're basically downscaling the old machine set. So what happens if you have max search? Let's say you have a machine deployment with replica 10 and you use max search 10. The very first thing we're going to do is we're going to create 10 new machines. So you have 10 new machines, 10 old machines. Okay. Then something gets stuck. The autoscaler tries to delete a new machine. It's going to downscale the machine deployment. And because essentially at that point, the machine deployment replica count is 9 and the machine set replica count is 10, it's going to downscale the new machine set. And everything is fine because it tried to delete a new machine and we actually downscaled the new machine set and accordingly deleted the new machine. But depending on this max search number, essentially, the number of replicas of the new machine set is different, and we're either going to hit like one code path or the other code path by either scaling down the old machine set or new machine set. So basically, you have to play this through with a few scenarios to see like what is max search, and are you going to end up with an empty old machine or an empty new machine to see if it works out the way that you expect it to work out. I don't know if that was super helpful. I know I have it in my head because I was going over it for a few hours and looking at the code. But yeah, that's roughly the problem. Max search influences if you're going to downscale old or new machine set, and depending on which machine actually gets empty, the autoscaler tries to delete either one or the other. And if basically the choices are not matching, you end up with slightly different problems, but both of them are problems. Because the moment when the autoscaler is not able to delete the machine it was actually trying to delete, it will try to delete another machine and another machine, another machine until there are no more machines anymore.
Right. So like, yeah, first of all, Miha, did you have any questions for Stefan before I start adding more information here?
I was just going to say that, Stefan, you've got a lot of information I understood a little bit, but obviously there was too many things happening. I think with the sequence diagram that is going to be put together, even this explanation in that doc or in the issue would help. Because it's like, maybe if I read it twice and, I'm using a pen and paper to write things down and do it, get the problem. But yeah,
Yeah.
just that feedback. Like, I think this all
Yeah,
needs to
no,
be
it makes
written down
sense.
just to understand all permutation
Yeah.
combinations.
I'm working
Yeah.
on putting that together for the issue. I think the other part that complicates this, and the reason that we found it, is because we're working with a user right now who is like part of their upgrade process has them kind of manually coordinating nodes, right? And so the old nodes, what they want to do is like coordinate them and kind of hold them in place. So they don't want the old nodes to be removed because it's part of their, compliance process or whatever. And so when they start the upgrade, they allow the old nodes to exist in an empty state for a very long time, like days, right? While the upgrade is taking place. So there's a period of time that's longer than normal where the number of nodes in the cluster or the number of nodes associated with a machine deployment is actually greater than the replica count that is reflected by the machine deployment. And when that happens, the cluster autoscaler doesn't have a notion of what the size should be, but it sees nodes in the cluster that have been empty for a long time, like more than 20 minutes. And it says, okay, I found an empty node. What node group is this thing part of? And it asks the cluster API provider, it says, hey, I've got this node. What node group is that part of? And cluster API will say, oh, that's part of this machine deployment, right? At this point in the upgrade, the number of replicas in the machine deployment is wrong from the number of nodes, right? So the cluster autoscaler says, great, I found this node. I don't think it should be in the cluster. It's part of this node group. I'm going to ask that node group to reduce its replica count, right? Because it says, I want this node to be gone. And so it marks the node, and in our case, it marks the machine as well with the delete machine annotation, and then it tries to reduce the replica count. And the problem is the machine deployment is undergoing an upgrade. So it has two machine sets underneath of it, the old one and the new one. And the old one is now the user has manually prevented nodes from being removed from the old one. So those nodes can't be removed. And when the replica count gets reduced, then what ends up happening, and I'm not sure how this works. I'll leave this more to Stefan's, court. What ends up happening is the new machine set has its replicas reduced. And so a new machine comes in and then it gets removed. And then the old machines, because of the process, they've been coordinated and everything. So no new workloads are going to the old machine. And now workloads are just lining up in the cluster because they can't get scheduled basically. That what Christian is saying, about the outdated revision, like that's what I was hoping that I could use outdated revision as another way to help identify this, but I'm still understanding how the upgrade works, so I'm still kind of working through it. Yeah, Neha, go ahead.
One last thing. When you were going through the whole process, you did mention that the autoscaler actually goes and annotates the machine, adds label on the machine which it wants to be deleted. So is there some sort of disconnect where, autoscaler is saying, I want this machine to be deleted, but Cluster API is looking at the machine deployment and is not looking at that annotation. So it's like that label. So it's like that label is sort of not serving any purpose. So I feel like yes, we know like you have the problem, but for the solution, it might be like both ways, like,
Right.
autoscaler and CAPI has to coordinate how they want things to work because autoscaler is expecting something to happen, but CAPI is just doing something.
Right. No, it's a great question, and I'm going to hand it right back over to Stefan because he knows that part.
Yeah, so the tricky thing is what autoscaler is doing and is adding a machine called, I don't know, delete machine something on a machine. But that is the problem here. I mean, one of the things producing the problem is this annotation is only considered when the machine set controller is downscanning a machine set. So you have a machine set, 3 replicas, there are 3 machines. One of these machines has the annotation, When you reduce replicas to 2, then the machine state controller will precisely delete exactly this machine. The machine deployment controller does not care and does not know about this annotation. And that's where the disconnect happens that you were talking about. So the machine state controller would do the right thing, but it would only do the right thing if it's getting downscaled. The machine deployment controller does not know about this annotation, so it's also not downscaling that machine set. The thing is just, I'm personally thinking that it's like also like conceptually not necessarily a good idea to try to remove empty machines during a rollout because maybe we want them there. So right, you could say maybe let's just fix it up that the autoscaler is actually able to delete those machines. I think the result will be that in certain scenarios, you are intentionally creating a bunch more machines so that workload can move over. The autoscaler will now, with the fix, be able to delete all of those, and then your workload has nowhere to go. So your entire rollout is just entirely stuck, and there's no way out of it. So that's what I'm concerned about. That's why I want to like stop the autoscaler from deleting empty machines during rollouts. I know we could fix the bug, and there's also another angle, which is basically the machine deployment control is really, really, really complicated. I would say that's probably like it's a top contender for the most complicated piece of code that we have in Cluster API. And I really don't want to make it more complicated than it already is by basically, based on what the autoscaler is sort of assuming, in some scenarios also making different scale up and down decisions because it's already extremely hard to reason through. That's like another angle. But even if you would make changes in the machine learning controller to essentially consider this annotation when trying to figure out what to up and down scale, I think even if you would do that, we still have the conceptual problem that we shouldn't delete empty machines during this whole process.
Pavel, and then I have also a comment, but I don't have a raise hand, so I queue myself.
My question would be, how do we know that a node is empty? I mean, how is it defined? How Capi knows that this is a node that's empty that should be deleted, which causes another node to be deleted, and so on, as we discussed. I mean, that's a question. I mean, what if we found a root cause of how, like in details, is that empty node determined among providers, which might be tricky, but I guess there is a template or machine set template for this, then perhaps this situation wouldn't have happened and there will be like extra check whether it is really an empty node that should be deleted, and some kind of A/B strategy could have been implemented. But first, validation, like, is it really that empty node that needs to be deleted?
So in this case, the cluster autoscaler is the one that is identifying the empty node. And it identifies the empty node by looking at the pods that are running on it, and then looking at the requests for those pods and comparing them with the capacity for the node. And then it has a utilization threshold that the user can set. And so if the number of pods on a node and the resources used by those pods is below the utilization threshold that the autoscaler knows about, then it will determine that that node is unneeded, is what it calls it, unneeded. Yeah, go ahead, Pablo.
I understand. Okay. What if there was maybe operator or some kind of a I don't know, scraper that would define that it really is the case? Because sometimes what shows resources that show, I mean, from my own experience working with Carpenter, the paths were very scattered around, and basically it was not always the real metrics that I would be able to see in Grafana. So what if there was an operator or maybe an agent running on the I'm not sure where yet, maybe in somewhere in providers that would integrate with that kind of a check, that would also integrate through mutating webhook with Cluster API.
I mean, I think it's possible. I don't think it's necessarily needed to solve this problem, but it would make for more accurate empty node detection, I suppose.
Yeah, although it's quite complicated and requires a lot of correlation, but that's my idea because then you would be like sure, like is it really that empty node or is it just a mistaken calculation of the resources? Because that
No, it's
happens.
in this case, I know it's an empty node. Like I'm not questioning the empty node calculations from the cluster autoscaler. Like I know they're accurate in this case, and that code is pretty well tested. So yeah, there are cases where it doesn't do as good a job as we might want, but I think improving that side is probably a separate investigation.
Hmm.
I agree.
Okay.
So first of all, Mike, thank you for all the work here, and if you need help, don't hesitate to reach out. Um, I I was thinking during the discussion if maybe we can look at this from a different angle. So my understanding is that what happening is that cluster autoscaler determine that a node is empty within a node group or autoscaling group, sorry. But at the same time, it does not recognize that in the same autoscaler group, there are nodes that are trying to move away their workloads. So it looks like that basically decision is taken on node by node basis, more or less. And this does not account for the fact that, yeah, you are there, but we are there for a reason, which is to relocate other workloads. Yeah, maybe a good idea is that not in this layer, but in the layer above, so in the cluster API autoscaler integration, we sort of embedded into this knowledge. So yeah, the core cluster autoscaler tell us, oh, there is an exceeding node or an unnecessary node, but before deciding to go on and delete the machine, we figure it out if it is expected in that moment. And so we basically, yeah, autoscaler told me that this node is in excess, but we defer acting on this information.
Right.
Yeah, just a crazy idea, but maybe we can sort of add on top of cluster autoscaler this knowledge of the entire set
Right.
that is missing and leading to this problem.
Right. That's essentially the solution I'm trying to work towards. The problem is like my knowledge about how machine deployments do an upgrade is not as good as it should be. So I'm having to kind of like run the upgrade and follow what our user is doing to see if I can exploit cluster API in the same way so that I can start to see like what information is available to the cluster autoscaler during this process. And so I think you're absolutely right. I think unfortunately it ties the autoscaler closer to the cluster API controllers because now the autoscaler has to understand how a machine deployment does an upgrade, which makes it a little more brittle. But I think the only way to solve this is for the cluster autoscaler to say, okay, if I've been requested to delete a node and I see that that node belongs to a machine deployment, I need to check to see if that node is currently undergoing an upgrade. And if it is undergoing an upgrade, don't delete that node. Just ignore the request to reduce the replicas.
Okay, so my proposal, Mike, is please do your research as soon as you're comfortable. If you want, I'm more than happy to jump in a Zoom call and try to figure it out if we can help you there.
Okay.
Stefan?
Yeah, similar. If we have an idea of a fix, I mean, on top of what Fabrice is saying, or so we have an first implementation of fix, also happy to test it out, or we can also, take a look via Zoom or something. I realized that capd only takes like 20 seconds to create a machine.
Right.
So
yeah. That's why
it's
I'm using
also
capd.
pretty easy with capd to reproduce a little bit and stuff.
Yeah.
Yeah, but
absolutely.
just let us know if you need help, essentially.
No, absolutely. And I think one last point I want to make, because I know we're getting close to meeting time here, is in the thread, there was kind of a mention of like, how does this work on AWS EKS, right? Because like, and we linked to the document about how upgrading works. I think it's interesting to note that EKS has like two upgrade processes. One of them is called the default upgrade, and the other one's called the minimal upgrade. And the minimal upgrade looks like it tries to do like a one-for-one replacement of instances. So your replica count never goes higher than what you expect. But the default case, the way the documentation talks about it is that when you do an upgrade, the desired count of that auto scaling group actually doubles in size. And it actually reflects the number of instances that it made to do the upgrade. And then when the upgrade is over, it like shrinks back down. So I have a feeling that if this is another way to look at it, and I'm not suggesting we do this, but I'm just saying in general, if a machine deployment's replicas change during an upgrade to reflect the true number of instances that were in there, then like the cluster autoscaler wouldn't be trying to delete like more than exists, right? It would be deleted. It would still be a problem for the cluster API controllers to figure out which ones to delete, but like at least the replica count would be an accurate reflection of what's
Sorry, before giving time to Pavel, Stefan, today we were looking at annotation
Yeah,
on the machine deployment
no machine set.
on machine set.
Yeah, they're on machine set.
And
but
it is
but I
only on
think
the last machine set. Yeah, yeah.
I don't remember that part, but I mean, so if you're looking at like a field where you can read the number of machines or something, we have a status field, right? It's in the status. The thing is
Right.
just, and I think spec is something that we can. So I think what we should not do, just in general, is that let's say you have a machine deployment, there's 5 replicas, you're triggering a rollout. We should not change the spec field, of course.
Right, exactly.
Right. I mean, because that's what the user gave us or the autoscaler gave us or something.
Totally.
But a status will just always reflect the current state. So if you're just
Right.
looking for the information, just look into the status.
Yeah, that's what I'm trying to figure out is can I use some of the status fields to like determine that there's like, okay, like if I see that the replicas is way higher than the actual spec replicas, it's like, is that indicative of an update that's happening? Like,
It could be also downscale, right?
yeah, okay. Yeah,
Because
right, if it's less than,
if you
right.
scale down, it might take a minute or something. No,
Right.
I mean, no, not even just a minute, right? Because if machine deletion is stuck, so you have 10 replicas, you want to go down to 5, you want to delete those 5 machines, they're stuck for a week. Status
Right.
replicas will have 10 for a week.
Right. You
It's
can't
not
just
even a
not-
rollout, it's just a downscale that is idle.
Right. But like this is where it gets really complicated. Like if a user decides to keep those extra machines around for a week because they want to or whatever, then like this is like never going to work properly, right? Because you're like putting your thumb on the scale basically.
Yeah.
All right, Pavel, please.
So basically, that is an example that there are two kinds of updates in AKS. I think this might actually be very useful, taking reasonable time, of course, and maybe do some extra checks. Because you can have those nodes annotated this way, you can have those nodes annotated like I don't know, ready for retirement or ready for being stale, but still would need to be decided by something like canary. Like you either go that route where this is scaled, or you either go that route and you go with that machine set. So that will be this action of machine set scaling, of course, with all the checks needed for updates, external updates, and so on. Or you go the other route, depending on the internal load balancer being service or wherever, cluster API service maybe even, and then then this is the actual action that I'm gonna go with, because every single validation and check that was satisfied actually made me go through that A to that B. Through kind of a canary approach, and of course annotations, taints, and maybe even webhooks. I need to get deeper into the code, but that's a very good point. I think it could work.
Yeah, I mean, I need to look at the information a little more and see what's available and then maybe I could have a better impression of if there's something missing, what we might need. But yeah, noted, Pavel. Thank you.
Okie dokie. So thank you again, Mike, for all the work, and thank you everyone for the contribution to the discussion. I think we are nearly the top of hour, so I will close the meeting here. See you next week.
Thanks, Fabrizio.